Did you know that electrostatic forces cause some really amazing things in nature? Think about a lightning bolt. It's a great example of electrostatics and can make the air around it 5 times hotter than the sun's surface. That's more than 30,000 Kelvin, and it's all because of the amazing power of electrostatic forces. Also, electrostatic force plays a crucial role in holding atoms together. So, in this video we will learn about the incredible force between two charged particles, which is explained by Coulomb's law. Suppose we have two objects carrying charges q1 and q2 and the distance between two objects is r. Now, according to Coulomb's law, the force between the objects is directly proportional to the product of their charges, that means q1 times q2. If you increase the charge on any object, the force will also increase. At the same time, the force is inversely proportional to the square of the distance r between the objects, which means that if you increase distance r between objects, the force will decrease. In simple language, you can say that the force is stronger if the charges are greater and weaker if the objects are farther apart. Opposite charges, that is, if one charge is positive and other is negative, they attract each other, while similar charges repel each other. Let's derive Coulomb's law step by step. Consider two charged particles with charges q1 and q2 and let the distance between them be r. According to Coulomb's law, the force between the two particles, F, is directly proportional to the product of their charges, q1 into q2, and inversely proportional to the square of the distance between them. To convert this proportionality into an equation, we need to introduce a constant of proportionality. This constant is called the electrostatic constant, represented by K. Now, we can write Coulomb's law as an equation. Force F equal to K into Q1 into Q2 divided by R squared. The SI unit of K can be easily calculated with this equation. We will first look at the units of each term. Force F is measured in newtons. Charges Q1 and Q2 are measured in coulombs. Distance between the charges r is measured in meters. Now let's rearrange the equation to isolate K. Now let's plug in the units, which can be given as. So the unit of K is Newton meter squared per Coulomb squared. Value of K is equal to 9 into 10 to the power 9 Newton meter squared per Coulomb squared. The electrostatic constant, K, can also be represented in terms of permittivity. Permittivity, denoted as epsilon, indicates a material's ability to resist or support the formation of an electric field within it. In simple language, permittivity is a measure of how easily a material allows electric field lines to pass through it. The constant K is related to the permittivity of free space epsilon naught, which is the permittivity of a vacuum, by the following relation. K equal to 1 by 4 pi epsilon naught. In different mediums, the permittivity epsilon usually varies because the ability of a medium to support an electric field depends on its molecular structure and properties. The relative permittivity epsilon r is the ratio of the permittivity of a material to the permittivity of free space epsilon naught. It is a dimensionless quantity that indicates how much more or less a medium supports the electric field compared to a vacuum. In most cases, the relative permittivity of a medium is greater than 1, indicating that it is more difficult for electric field lines to pass through the medium compared to a vacuum. Some key takeaways that can be taken from Coulomb's law are: if K increases, force between charges also increases. The force could be either attractive or repulsive. Secondly, if permittivity increases, the force decreases, that means they are inversely related. Third, if force that we obtain is positive, then it is repulsive, as force can be positive only if the charges are alike, that are either positive or negative, and charges with the same sign repel. And if the force obtained is negative, it means the force is attractive, as it can be negative only when charges are with opposite signs. Now that we have understood Coulomb's law, let us solve a few NEET previous year questions. This question appeared in NEET 2020. The question says to find the acceleration of an electron due to mutual attraction between electron and a proton when they are 1.6 angstrom apart. The mass of electron and the charge on one electron is given in question. Also the value of 1 by 4 pi epsilon naught is given. We have 4 options as follows. Let us solve it. The force of attraction between an electron and a proton can be calculated using Coulomb's law, which is F equal to K times Q1 times Q2 divided by R squared, where F is the force, K is electrostatic constant whose value is 9 into 10 to the power 9 Newton meter squared per Coulomb squared. Here it is given that Q1 is electron and Q2 is proton. The magnitude of the charge on both electron and proton is 1.6 into 10 to the power minus 19 Coulomb, but with opposite signs. R is the distance between them, which is 1.6 angstrom here. Now we know that 1 angstrom is equal to 10 to the power minus 10 meters. Now let us calculate the force between electron and proton, which are 1.6 angstrom apart. F equal to K into minus 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 10 squared. Let us put the value of K. Solving further, 9 into 10 to the power 9 into minus 1.6 into 10 to the power minus 19 is squared divided by 1.6 into 10 to the power minus 10 squared. When we solve it further to simplify, we get force equal to minus 9 into 10 to the power minus 19 newtons. Here the minus sign indicates that the force is attractive, so we can ignore it further. We have to calculate the acceleration of an electron due to mutual attraction. And we know that force is mass times acceleration. Therefore, we can say that mass into acceleration equal to 9 into 10 to the power minus 90 newtons. It is given in question that mass of an electron is 9 into 10 to the power minus 31 kilograms. Therefore, 9 into 10 to the power minus 31 into acceleration equal to 9 into 10 to the power minus 90 newtons. Solving further, we get acceleration equal to 9 into 10 to the power minus 90 newtons divided by 9 into 10 to the power minus 31. On solving, we get acceleration equal to 10 to the power 22 meter per second squared. Therefore, the acceleration of an electron due to mutual attraction between electron and proton is 10 to the power 22 meter per second squared. Hence, third option is correct. Let us solve another question which appeared in NEET 2019 based on Coulomb's law. In this question, 2 point charges A and B, having charges plus Q and minus Q respectively, are placed at a certain distance apart, which is not known here. It is given that force between these 2 point charges is F. Now what is happening? Here the 25% of charge A is being transferred to charge B. And we have to find the new force between 2 charges. The options for the questions are as follows. Let us first understand what happened with charge A. Now initially charge A was plus Q, but when 25% of charge A is transferred to charge B, charge A finally becomes plus Q minus 25% of Q, which is equal to plus Q minus 25 by 100 into Q. On simplifying, we get plus Q minus 1 by 4 into Q, and on further solving, charge A comes out to be 3 by 4 Q. Now let us discuss charge B. Initially charge B was minus Q, but when it takes 25% of charge A, it becomes minus Q plus 25% of Q, which is equal to minus Q plus 25 divided by 100 into Q. On simplifying and solving, we get minus Q plus 1 by 4 into Q, which comes out to be minus 3 by 4 Q. Now, Let us write the equation of force for the initial condition when there was no transfer of charge. Assuming that the distance between charge A and charge B is r. Let us say the initial force is F. Therefore, the initial force F is equal to K into Q into minus Q divided by R squared is equal to minus K into Q squared by R squared newtons. Let us say equation 1. Now we have to write the equation for the new force after the 25% of charge A is transferred to B. Let us say the new force is F dash. Therefore, F dash is equal to K into minus 3 by 4Q into 3 by 4Q divided by R squared. On solving we get F dash equal to minus K into 9 by 16 into Q squared divided by R squared in. Let us call it equation 2. Now dividing equation 2 by 1 we get F dash by F equal to minus K into 9 by 16 into Q squared by R squared divided by minus K into Q squared by R squared. On solving and cancelling out various terms we get F dash by F equal to 9 by 16. Taking the F to right hand side, we get F dash equal to 9 by 16 F. Therefore, the new force F dash is equal to 9 by 16 times F. Hence we can say that third option is correct. In conclusion, we learned about Coulomb's law and its role in determining the electrostatic force between charged particles. We also explored how to apply this law to solve problems involving charged particles, as demonstrated in the NEET previous year questions. We hope that you have understood Coulomb's law. Now, here is a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve NCERT-based MCQ tests of this chapter on EduRev. And that's not all, you also get amazing courses for class 11 and 12 physics and much more for your NEET preparation.